Okay, so completing the square is another method for solving quadratics. What we've been doing is we've been taking square roots of both sides. When you see something like x squared is 64, you already knew when you came in here that x would have to be equal to what? X had to be equal to what? 8 or negative 8. There were two numbers that made that true. The way we worked that out in class is we said if you've got x squared equals 64, and you have a bright idea of taking the square root of both sides, what must be here on the right side? Plus or minus, okay? Square root of x squared is x, so x is equal to plus or minus 8. That's how we make sure that we programmatically get both of the answers, the positive and the negative. Same thing here. If I have x minus 1 squared equals 64, because I've got something squared all by itself, that's why I'm taking the square root of both sides. So square root here, what goes here? Plus or minus, okay? What do I get on the left? Yeah, x minus 1 equal plus or minus 8. X is equal to 1 plus or minus 8. You do not leave your answer like that because this is middle school math. What's 1 plus 8? 9. 1 minus 8? Negative 7. So your answers are 9 and negative 7. Okay? Now, if I look at the next one, what is being squared? X plus 4. I want something squared all by itself. What is keeping x plus 4 squared from being by itself? The 2. The 2 that is what? Multiplied, subtracted, added, divided. Multiplied. So if it's multiplied by 2, I can undo that by what? Dividing both sides by 2. And then I get x plus 4 squared equals 64. Now what do I do to solve this guy? Take the square root of both sides. X plus 4 equal plus or minus the square root of 64. X plus 4 equal plus or minus 8. X equal negative 4 plus or minus 8. So x is equal to 4 or negative 12. Okay? So that's what we've been doing by taking the square root of both sides. Okay? So if I take the square root of this side is what we call a perfect square. It is x squared. This side is a perfect square. It's x minus 1 squared. When I divide by 2, this becomes a perfect square, x plus 4 squared. So if I can get a perfect square on one side of my equation, it's pretty easy to solve the equation. Okay, it's easier than factoring and easier maybe than quadratic formula. So is there a way that I can, this one when I look at it now, it's not a perfect square, okay? First of all, what if I tried to factor it? If I tried to factor this, I would need two numbers to do what? Two numbers that multiply to, come on guys, multiply to 2 and add to 4. What are the factors of 2? 1 and 2. Is there any way I can conceive of adding those together and getting a 4? No, so I cannot factor this. This one can't be solved by factoring, okay? The only factors are 1 and 2, so I can't factor it. It's not a perfect square. I can't take the square root of both sides, but can I work some algebraic magic to make it a perfect square? And that's what we want to talk about. Let's look at, from a geometric standpoint, x squared is a perfect square. So what if I drew a box and the dimensions of this box are x by x, okay? What is the area of this square? X squared, okay, that is the area of this square right here, okay? Now, what if I drew a rectangle that was x by 1, okay, and this rectangle is x by 1. This rectangle is x by 1, and this is x by 1. What is the area of each of these rectangles? X, okay, so this is, the area is x, this area is x, this area is x, and this area is x. So, what is the area of this plus this plus this plus this plus this? It's x squared plus 4x. Okay, so the area that you see in yellow, let's just go ahead and highlight everything. All of this, the area is x squared plus 4x. Okay, everyone agree with that? Okay, now if you look at this shape, is that shape a square? No. Can you see something I could do to make it a square? Yeah, so what's the area of this little square? 1 times 1. This is the area is 1. What about this one? These are all area 1. Okay. So now, is this whole big thing, is that a square? And don't argue that it doesn't look like it should be. So that's a perfect square. So what do you think? This is not a perfect square. What do you think a perfect square would be? X squared plus 4. It looks like geometrically that's a perfect square. Okay. How do I factor this guy? I need two numbers that multiply to what? 4 and add to 4. Are there numbers that multiply to 4 and add to 4? 2 and 2. So I could write this as x plus 2 times x plus 2. What's another way of writing x plus 2 times x plus 2? X plus 2 squared. Does that feel like a perfect square? Yes. That is now a perfect square. X plus 2 squared is a perfect square. Okay? So this is a geometric way of looking at something, a polynomial, being a perfect square. We're not going to do this every time, but this is sort of to give you a visual of what this looks like. So if I had x squared plus 4x plus 4, it doesn't take a whole lot of work to realize that's x plus 2 squared. If I had that equal to something, how could I solve this? By taking if this x plus 2 squared equaled a number, I would solve by taking what? Square roots of both sides. So if I can transform something into a perfect square, I can solve by taking square roots. Okay? So we can see that this is what we just did. X squared plus 4x plus 4. We got to this being x plus 2 times x plus 2, which is x plus 2 squared. Okay? So we can see that that is a perfect square. Okay? So if I can transform something into being a perfect square, then I can solve by taking the square roots. Okay? So let's look at this problem. I want to solve x squared plus 4x plus 2 equals 0. Okay? We recognize this is not a perfect square. Okay? But this is a perfect square. So I know that that is a perfect square. And then this one right here is not a perfect square. So I got a couple things I can do. How can I make this equation into a perfect square? Okay, I could add 2 to both sides. Okay, so I could say, what if I took x squared plus 4x plus 2 equals 0, and what if I added 2 to both sides of that equation? Okay, what would I get on the left? I would get x squared plus 4x plus 4 is equal to 2. You could do that. You could subtract the 2 from both sides, and then you would have to add what? 4. Okay. If I subtracted 2 from both sides, I would get x squared plus 4x equal minus 2. To make it a perfect square, I would have to add 4 to both sides. So I would get x squared plus 4x plus 4 equal 2, either way. Okay. So if I get this one, what do I have on the left? This is a what? It is a perfect square. So because I can find two numbers that multiply to 4 and add to 4, so this is x plus 2 times x plus 2 equal 2. Another way of writing that is x plus 2 squared is equal to 2. Now I've got a perfect square. How do I solve this equation? Just take the square root of both sides. So when I take the square root of both sides, I get that x plus 2 is equal to what? Plus or minus square root of 2. So x is equal to what? Negative 2 plus or minus the square root of 2. That's the solution to this equation, okay? So when I started out, it would not factor. It was not a perfect square. So I did something called completing the square. Make one side a perfect square so that you can take the square root of both sides. Okay? So here's where we need to get a little bit more precise about what we're doing. I want to get things that look like perfect squares, you know, x plus k squared or x minus k squared. I want to convert things to perfect squares, okay? What happens when x plus k squared, that's the same as what? X plus k times what? When I multiply these together, please don't say it's x squared plus k squared. What is it? What happens when I multiply these together? What do I get? X squared plus what? Kx plus kx plus k squared. So this is x squared plus 2kx plus k squared, okay? And there is a typo here. So this is x squared plus, correct it right there in that. So x squared plus 2kx plus k squared, okay? Does everyone see that, okay? Now when I'm factoring, if I'm factoring something that looks like this, I need two numbers that multiply to give me what? I'm here. Two numbers that multiply to give me C and add to give me B, okay? Now let's look over here. I don't need two numbers that multiply to give me k squared, okay? I want a perfect square. I need one number that when you square it, you get what? K. And when you add k and k together, you get 2k, okay? So that's what I need for something to be a perfect square, okay? So if you look at it, you've got x squared plus 2kx plus k squared, okay? Somebody tell me, how do you get from, I want to figure out the relationship between these two things, okay? Describe for me how I get from here to here. If I've got 2k, what do I do to take 2k and turn it into k squared? What do I do? 2k, I want to turn it into k squared. What do you do? 2k has to be divided by what? 2. When you divide 2k by 2, you get what? K. And then what do you have to do to k to make it a k squared? Yeah. So if I'm going in this direction, I have to take 1/2 and then I square it. If you were to take 1/2 of this number and square it, you're in the form of a perfect square. Okay. How do I get the other direction? How would I go from here back over to here? If I started with k squared, what would I do to make it into a 2k? I would do what? I would take the what? Take the square root of k squared becomes k, and then I would have to do what? Yeah. So in this direction, I would have to take the square root, then multiply by 2. So this is what a perfect square looks like when you multiply it out. X squared plus 2kx plus k squared, okay? That's what the perfect square looks like. So if I know what this number is, tell me how I get from this number to this number. You do what? You divide it by 2 and then you square it. To get from this number to this number, you take the square root and then you double it, okay? So here's what we need to do. If I'm trying to solve x squared plus bx, if I'm trying to make that a perfect square, what do I have to do this number? I have to take what? Half of this number and square it is what makes this a perfect square. Okay? So that's the whole crux of it, is to get a perfect square, you're going to have to take half of b and square it. That makes this a perfect square. Okay? So let's do an example. X squared plus 2x minus 3 equals 0. So first thing to do, move that constant over to the other side. So I get x squared plus 2x equal 3. Okay. Now, what I need here, for this to be a perfect square, I've got to take half of this number and square it. Okay, so what I'm going to do, I'm going to write x squared plus 2x. What is half of 2? 1. What is 1 squared? Okay, so I'm adding 1 squared to that side of the equation. Now, if I decide that I just would love to do that on the left side of the equation, what must I also do? I must do it on the right side of the equation. Okay. Okay, so what I did was I took half of this number, which is 1, and I squared it. Okay. Now, the left side will factor. Is there a number that you can multiply and get 1 and add and get 2? What numbers multiply to 1 and add to 2? 1 and 1. So this is x plus 1 times, what is this? X plus 1 times, okay guys, 2 numbers. The left side, you need 2 numbers that multiply to 1 and add to 2. What numbers do that? 1 and 1. So this factors as x plus 1 times x plus 1. It's x plus 1 times x plus 1. So I've got x plus 1 times x plus 1. Is that an accident? Did it just happen like that? No, that's what the hell I wanted to happen. Okay, I wanted it to be x plus 1 times x plus 1. Pardon the French. Oh, and I am recording, right? So this is 4. So what's another way of writing x plus 1 times x plus 1? Yeah. This is x plus 1 squared equal 4. Okay, now what can I do? Yeah, the whole purpose was I can now take the square root of this. Okay, so when I take the square root, what do I get? I get x plus 1 equal plus or minus what? The square root of 4. Yeah, so x plus 1 equal plus or minus 2. X equal negative 1 plus or minus 2. So what is x equal to? 1, negative 3. Okay. So completing the square is a way of taking any quadratic, making it a perfect square, hence the term completing the square. Then you're allowed to solve it by taking the square roots of both sides. So the key to this is you look at the number that's in front of your x term. To make it a perfect square, what do you have to do with that number? You have to take what? Half of that number and square it. If you're adding that to the left side of the equation, you must also add that to the right side of the equation. Okay, let's look at another example. This is x squared minus 2x equals 7. Okay, now what's half of negative 2? Negative 1. What happens when you square a negative 1? You get a 1. So every time this is always going to be a positive number right here. Okay, so I'm adding a 1 to that side of the equation. Okay, so half of negative 2 is negative 1. Half of negative 2 is negative 1. Negative 1 squared is 1 squared, so it's just 1. If I'm adding that to the left, what must I do on the right? I must add that same thing on the right side of the equation. Okay? Negative 1 squared is 1. This number is always going to be positive. Okay, negative 1 times negative 1 is 1. I always just, this number is always going to be positive, so I don't worry with negatives and positives, okay? I'm always adding a positive number when I complete the square, okay? Now, what happens here is this, how does this guy factor? What is this? X minus 1 squared. Because you're looking for numbers that multiply to 1 and add to negative 2. What numbers can multiply and give you a 1, and you can add them and get a negative 2? Negative 1 and negative 1. So this is x minus 1, x minus 1. So you should be able to just go straight to your factorization. It's x minus 1 squared equal 8. Okay? So you take the square root of this, that's x, copy that sign down. If this is 1 squared, you put a 1 right there. Okay? X minus 1 squared equal 8. Now how do I solve this? Yeah, take the square root of both sides, and that gives me that x minus 1 equal plus or minus the square root of 8. So this is x equal 1 plus or minus 2 square root of 2. Okay? How does this one feel? Does this feel okay? Okay, this is algebraic manipulation to complete the square. We'll be doing this a lot right after spring break. So hopefully this will be more solid when that time comes and you had more exposure to it. Now, it gets a little bit more complicated when we see things like this. What we've been doing before, we've been doing x squared plus bx plus c. Okay? Now we're trying to factor something that looks like what? Ax squared plus bx plus c. Okay? Just a little bit of difference of what happens. Okay? So let's take a look at this. Two x squared plus 4x minus 3 equals 0. Move that negative 3 to the other side. So 2x squared plus 4x equal 3. Okay. Now, what I must do every time when it gets like this, whatever number is in front of x squared, I need to factor that out. What's in front of the x squared? Yeah, so I'm going to write a 2 here. And this is x squared plus what? 2x equal 3. Okay? So now I've got to complete the square. So I've got 2x squared plus 2x equal 3. Now look inside this box. How would I complete? Did I do something wrong? I what? Yeah, I'm about to do something. How do I complete the square here? What has to happen? Half of 2 is what? 1. So I need to add 1 squared. Okay. Now, what did I add to the left side of the equation? I did not add 1 squared. What did I do? I did not add 1. I added 2. How did that? Why does that? This is the big trick. I added a 1 inside the parentheses, but that 1 is multiplied by 2. So what really changed on the left side? What did I add? I added 2. If I do that on the left, what must I do on the right? It is 2. Okay? So by adding 1 right here, what is that 1 multiplied by? 2. So this is 2 times 1. So to get from here to here, what did I really do? This is this equation to this equation, I added 2. If I'm going to add 2 on the left, I've got to add 2 on the right. Okay? So this becomes 2 times. This is now a perfect square. What is this? This is x plus 1 squared equal 5. Okay? Now, to solve this by taking the square roots, what do I have to do first? Yeah, divide everything by 2. So that's where I get x plus 1 squared equal 5/2. Now when I take the square root of both sides, I get x plus 1 equal plus or minus the square root of 5/2. So x is equal to -1 plus or minus square root of 5/2. Okay, this is where people tend to make mistakes in completing the square. Okay. Let me do another example. Do I have another example, or am I done with that? Yeah, I do have another example. Let's work this one. Okay, so this one, it has a number other than 1 in front of the x squared. What's the first step? Yeah, so take that 5 to the other side. Now, what has to be factored out? No, a 9. A 9 has to be factored out, okay? Because that's what's in front of the x squared. So I have to write this as 9 times x squared. How do I factor a 9 out of a 6? Okay, so what this says, 9 times x squared is 9x squared. What do you multiply 9 by so that you get -6x? Does everyone agree? When I multiply that, what do you get? What happens when you multiply 9 times -6x over 9? What do you get? -6x. Okay, so it's 9. You have to factor the 9 out. Okay, 9 minus 6/9 x equal -5. Everyone see what that is? That's a little bit different. Normally you're thinking, oh, I can factor a 3 out of there. You can, but we are required to factor a 9 out so that I can get this in the form that I can complete the square. Now 6/9, I can make it a little bit easier if I rewrite that as what? 2/3. Okay, so this is 9 x squared minus 2/3 x equal -5. Now to complete the square, I have to do what? I have to take what of this number? Half of that number and square it. So what is 1/2? What is 1/2 of 2/3? What's 1/2 of 2/3? 1/3. Okay. So I've got to add, what have I got to add here? 1/3 squared. Okay. That's what makes that a perfect square. Now, what did I add to the left side of the equation? I did not add 1/3 squared. I added what? 9 times 1/3 squared. If I add 9 times 1/3 squared to the left, what do I add to the right? Yeah. Plus 9 times 1/3 squared. Okay. Everyone with me there? Okay. So this is 9. What is this now? This is x minus what? I feel like people are thinking this is still magic, okay? What numbers multiply to give you 1/3 squared? 1/3. 1/3 and 1/3 will multiply to give you 1/3 squared, okay? How can I add them together and get a -2/3? They have to be what? -1/3, -1/3. This is x minus 1/3 times x minus 1/3. So to get from here to here, it's just x minus whatever that number is, 1/3. All of that squared is equal to -5 plus, what is that, 9 times 1/9? Okay. So this is, so 9 times x minus 1/3 squared equal what? -5 plus 1. That's -4. So 9 x minus 1/3 squared equal -4. Okay, what do I do next? Yeah, divide everything by 9. So x minus 1/3 squared equal negative 4/9. Now what do? Take the what? Square root of both sides. So I get x minus 1/3 is equal to the square root of negative 4/9. Okay. So when I take the square root of negative 4/9, it's going to be what kind of number? It's going to be complex. Okay. So yeah. So what's the square root of negative 4? 2i. What's the square root of 9? 3. Okay. So, and what did I mess up? What did I mess up? Yeah, plus or minus. So this final answer is x equal 1/3 plus or minus 2i over 3. Yeah, this one was a little bit complicated, okay? This one might be easier when we get to the quadratic formula, okay? That's just another method for solving, okay? Well, that's why I'm here to help, okay? That's why you've got Nadia and Will sitting near you.